Oh, well, hello, hello. All right, let's just get on the shuttle view and I'll go ahead and wait approximately 10 or 15 seconds to see if we got that display update. She's an old game from 2007, so we may expect a little bit of interesting technical issues. And look at that, we got it to work the first time. Absolutely amazing. And how about if we go internal? Let's take a look at that. Yeah, I figured as much. Internal view. She doesn't like the internal view. Let's go back and see if we can't get that display update again. Old game from 2007. Let's see here. Let's do... Can we do window capture instead? Let's try that. Window capture. I figured as much. Okay, well I've got a cheat for this. So Alt screen, Alt tab, and then we just do that, and that should work. Ah, there we go. Okay. All right. If someone remind me before I alt tab to to turn that back off. Um, we still got the count. And how is the moving of the screen? Perfect. Okay, we're good. Hello, hello. Thanks for joining. Switched it up to MJCI. I see. I'll have to go back and change the credits. Let's go ahead and get our audio systems powered up. The intercom, the air ground, and the air-to-air, believe it or not. Air-to-air radio for ISS docking and such.
Columbia, this is Launch Control. Are you ready? Columbia, loud and clear. Over. Copy that. Columbia, out.
Yeah, once reentry shuttle comes out. Oh, you're telling me. Ranch, I wanna I wanna talk about the shuttle and reentry so bad. So bad. I might ask Petrie if there's anything I could talk about with it, like maybe the Ops 200 transfer procedures or something, you know, just to tease a little bit out there and talk about what's in there, because I'll tell you what, some of the stuff in that shuttle is done better than any other shuttle that is currently out available. So of course it's got its re-entryisms, but
CDR. Roger. PL2. Copy that.
Alright. And there's no one else on this mission because it's STS-1. Notice the white booster tank. That's right.
Columbia.
The most you could say is that the shuttle is the shuttle. Yes, exactly, right? So yeah, right now, just, you know, until shuttle comes out in re-entry, because flight gear never works for me. I've tried installing it about 15 times. And the same thing happens for a couple of the NASP devs too. Until the space shuttle mod and orbiter is getting good, or until like you can actually, you know, do a thing, or until re-entry comes out, and we will be doing this very old 2007 game. So it's not bad though. Everything's 2D, but you know. This space shuttle vessel. IMU alignment complete. We show 28 degrees. Everyone is saying that it's like NASP. It's like NASP, but it's not there yet. It's not like NASP. 90% of the things aren't simulated or are like incorrect, and you know, computer is pretty cool in it, but other than that, it's just there's not much you could do at the time being. So it's very work in progress, and I expect one day it to be like NASP, but it's not there yet. So because I want to have some actual objectives to do, we'll just be doing this. You know, we can do our rendezvous and all of that. So.
Columbia, this is launch control. Over. Cabin vent, over. Roger, cabin vent.
Alright, time to transfer the primary computer, primary avionics software to the backup flight system. So we'll go ahead and we will enable the BFC display. Got BFC memory. We'll go ahead and do the pass BFS transfer enable. Pass is the primary avionics software system. So item 25, execute. In real life, this actually took like 10 minutes to complete, but in here it's instantaneous.
Columbia, this is launch control. Over. Cabin vent. We copy cabin vent to enable.
Cabin vent to enable, sure.
Flight control. Columbia, cabin vent check complete. Over. Columbia,
6, 7, 8, 9, set.
Columbia, load op 1, over. Roger, ops 1.
Okay. We'll go ahead and load our flight plan. So ops 101 for the ascent program.
Ops 101, complete.
Spec 99. No faults here. We will resume. And we will go ahead and activate the ascent program on the backup flight system now. So flight plan will be loaded into ops 1.
Flight plan loaded into OPS 1. Copy, Columbia.
101.
Columbia, go for main propulsion system power off.
Alright, supplying helium pressure to the main propulsion system for pressurizing of fuel and pneumatic control, which is also run through the helium system in this portion of the mission.
We confirm main propulsion system to enable. Copy that, Columbia. Columbia, ready for abort advisory check.
Okay, we've got the abort advisory.
Columbia, Houston, Roger, abort advisory
Clear.
check.
Okay, good clear. Alright, 9 minutes and holding.
Control, T-minus 9 minutes and hold. Columbia, copy that, out.
Alright, internal or external?
Give me comms check. Confirm go for launch. Payload manager.
Go for launch.
Shuttle engineering.
Looking good.
Weather.
We confirm. Go for launch.
Safety mission and insurance.
Yeah, go for launch.
PLT.
Copy that.
Okay. Waiting on a launch directory now.
Launch directory is go.
Okay.
Columbia, this is launch control. Resume countdown.
Copy that.
Event time activated. What are we looking for today? Internal or external view? Okay, good. Looking good there. Alright, let's write it up.
Track crew
For
access
access
on.
arm.
We confirm.
Okay, APU pre-start.
APU pre-start.
Connect fuel cells to essential buses. Complete APU pre-start. APU pre-start complete.
APU pre-start complete.
Columbia, wait confirm. Columbia, flight control go for APU start.
We copy.
Okay, APU start. Fuel tank valves open. APU 1, 2, and 3 are start. Pressure is green and stable. Alright, pump pressure spin up. We are good. Yeah, I can do that. Obviously it's not going to show up on like stream videos, but I can do that on the main one.
Columbia,
Yeah.
you are out. Internal power.
Copy that. Internal power.
Okay. Internal power.
This is launch control. APU jet deployed.
Roger. Light control.
Columbia, initiate hydraulic jet over.
Roger. Light control.
Hydraulic check. Rudder looks good. Split rudder looks good. Let's check out that engine gimbal. Engine gimbal is good. Spread and launch configuration.
Hydraulic jet complete.
Columbia. Houston. Copy that.
Columbia, this is launch control. Oxygen band rose. Looking good. Columbia,
Alright,
We confirm.
the beanie cap is retracting now. We will begin tank pressurization.
control. Columbia, APU, power off to inhibit.
Okay,
Copy. Light control.
and we've got good LH2 pressure and good LO2 pressure. APU power off to inhibit.
We copy. Light control.
Post advisory is complete.
Columbia. Light control. APU. Power off to inhibit.
Copy that, Columbia. Columbia, now at T-minus 80 seconds and counting. You are go for launch.
Roger that. Light control.
Alright, we looking inside or outside? How are we doing?
One minute.
$40 seconds. Out? Okay. You got it.
Thirty seconds and counting.
Now at T-minus 30 seconds and counting.
Roger. Out.
Alright, D-minus 15 seconds coming up.
15 seconds.
Begin countdown to liftoff. 10, 9,
T-minus 10. We'll go for main engine start. 7, 6. We have main engine start. 3, 2, 1. Booster ignition and liftoff.
Columbia.
Liftoff for America's first space shuttle. And the shuttle has cleared the town.
It's probably nostalgic. I like these graphics too, and in fact the model on this for 2007 looks really good. But there's definitely like a nostalgia factor because the very first Microsoft Flight Simulator had the same thing where it was like a 3D cockpit, but it was 2D, and you had to like right click into the panels, and then you got a 2D pop-up and you would flip switches that way. And in fact the 3D cockpit doesn't even reflect the actual panel state of the switches, which is funny, but the original Flight Simulator for Microsoft worked that way, so.
Columbia, Houston, go throttle up.
Houston. Columbia. Go. Throttle.
Honestly, these particle effects on a solid rocket booster are
1%.
pretty good. If you've ever seen a shuttle launch,
Columbia. Max Q.
the
Over.
fire doesn't come out like a fire. It just comes out pure bright white like this. So it's definitely not bad.
Columbia, Houston, 2 minutes.
Okay, here we go. Stand by for SRB separate.
SRB separate. Columbia, Houston, SRB separate. Complete.
Roger. SRB separation.
Oh, the smoke at launch. Yeah, well, it's 2007. What do you want? And those boosters will be recovered and reused.
Altitude 200,000 feet.
Recover, refueled, and reused. Every part of the shuttle was completely reusable, except for the external tank. So, not, a lot of people know that the shuttle, of course, is reusable, but they don't know that the actual solid rocket boosters are also reusable. Okay, let's just go ahead and double check the flash evaporator.
Altitude
Evap out temp
130,000
is less than 60, so we've got a good flash evaporator.
Altitude 250,000 feet.
I mean, when this game was made, they were still using like frickin' CRTs.
Altitude 206,000 feet.
Yeah, also ray tracing can mess up the like original intended
Roger that. Houston, negative return.
look, you know. Sometimes light in games are manually done for reasons.
10,000 feet per second.
Okay, 4 minutes to Miko. Mark, 4 minutes to Miko, 51% propellant remaining. Chamber pressure looks good. Engine manifold pressures are looking great. Regulator pressure is great. Of course, the pneumatic tank pressure is looking great. Helium tank pressure is looking great. And helium regulator pressures are looking great.
Feet per second.
Nothing super spectacular in this launch. It's not it's not as interesting to watch as the Saturn, of course, since it's not a staged vehicle. And there's no roll to heads up like there is in most shuttle missions. So this one's just kind of, it's just gonna look like this till the end. Yes, DET says 94 because it rolls to 100 minutes instead of 60. So you're able to do 1 hour and 1 hour and 40-minute countdown in the shuttle. It's quite weird, but oh, look at that. Our ascent trajectory here. We've got a good Ops 103, and we've got the good zoom in for the final leg. Time remaining to main engine cutoff is 2 minutes 30 seconds. And we heard the call out for 50,000 feet per second, I think is what he said.
Columbia, Houston, single engine press to Miko. Over.
Single engine press to Miko. In the event of a 2-engine failure, the space shuttle would continue to make orbit. Angle of attack is 13 degrees. We are accelerating at 2.6 Gs.
18,000 feet per second.
Here we go, 18,000 feet per second. That's what it is. We're about to hit 19,000 feet per second. Mark, 19,000 feet per second. Here we can see we've actually nosed down just a little bit. Yeah, the displays update, but switches don't. Like, for example, if I armed the squib here for AV Bay 1 fire suppression, you could see the switch does not update. And for good reason, too. Could you imagine having to take a picture of this panel for every possible switch configuration? You'd have trillions of photos by the end, just on that one panel alone. So, yeah.
Houston, Columbia, Miko on schedule.
Copy, Columbia. Mako on schedule. Columbia, Houston, external tank separation armed.
This
We
part
have
happens
Houston.
automatically. There we go. ET SEP complete.
Houston, Columbia.
And that's gonna burn up in the atmosphere since we're actually still suborbital.
Columbia, Houston, you are go for OMS burn.
Roger. OMS burn in progress. Houston, beginning altitude adjustments. Auto sequence start.
Roger, Columbia.
Alright, now we'll get those OMS engine valve breakers turned on. And we'll go ahead and pressurize and arm the OMS system. The shuttle is going to make its maneuver towards the insertion attitude.
Houston, Columbia. Altitude adjustment complete.
Copy that, Columbia. Columbia, Houston, confirm OMS burn in progress.
Copy that. Houston, OMS burn in progress.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, ignition. Good numbers here. One minute to shut down. But yeah, we can see here the space shuttle computer is actually able to update its weight in real time as it burns. The Apollo computer was good at this, but this is so much like a closer approximation to the weight than what the Apollo computer was capable of factoring in. These OMS burns they're on rails because it is 2007. Everything RCS related, however, is not on rails. Those are live translations. There's no trajectory snapping after a maneuver is complete or anything like that. Because trajectory snapping does exist, we are able to do something like time skip in the middle of a burn to fast track it to completion. Let me get that checklist out of your way. Yeah, sometimes the checklists can be, you know, a little bit in the way.
Columbia, go for drops. 105.
Okay, preparing for OMS2. So an OMS1 is required to get the apoapsis above the atmosphere. And then an OMS2 is performed to circularize. In most shuttle missions, this is not required. However, on the earlier ones, an OMS1 is traditionally performed.
5 complete. Houston, beginning altitude adjustments. Auto sequence start.
Roger, Columbia.
Exactly. And these big engines will never be lit for the rest of the mission. So,
Houston, Columbia. Altitude adjustment complete.
Copy that, Columbia.
Houston, Columbia. Dumping complete.
Roger that,
okay,
Columbia.
dump is complete. We can go ahead and switch off the main propulsion system. And open up the H2 pressure line vent. And we can stow the center line latch and the umbilical doors.
Houston, Columbia. Umbilical doors closed.
Roger that, Columbia.
Yeah, well, it kind of is. Yeah, it kind of is. They did buy an airplane and like gut it to make the cockpit, so.
We confirm APU. Power off.
Copy
Okay,
that, Columbia.
APU shutdown. All right, all three APUs powered off. It's a lot of switches for the APU. I mean, there's three of them, but even just one of them has like 6 or 7 switches. It gets crazy. Okay, coming up
Columbia.
on the burn.
Houston, confirm lateral mass burn.
Copy that. Houston, 1S burn in progress.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Thrusters go. Final circularization. We can see our current periapsis coming up to meet our target periapsis, and then we will go ahead and raise our target apoapsis to 161. Not much to see on the outside. It's very dark outside. So we'll go ahead and we'll just chill inside. Watch the displays. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Shutdown. Okay, chamber pressure is good. Let's start dumping the LH2, and we'll disarm the OMS.
This is Columbia. Dumping main propulsion system.
Roger now.
We will go ahead and turn off the ascent thrust vector control, engine interface unit, and master events controller. We will close the main propulsion system thrust vector control
Houston,
isolation
Columbia,
valves.
main propulsion system, power off.
Copy, main propulsion system.
We will go ahead and enable our vernier thrusters. And we'll go ahead and turn flight control power on. We will manually use our thrusters here to align ourselves. With 0, 0, 0.
This is Columbia.
Okay.
Altitude adjustment complete. Over.
Houston, Columbia, over and out.
In the proper attitude for the mission, we will go ahead and set our brake heaters to auto. We'll go ahead and activate various other heaters for the gas generator and fuel pump, the lube oil line. We'll need the tank and fuel line and water boiler, and then of course the hydraulic heaters for our aero surfaces. We'll get the forward RCS jet, a left and right OMS pods, and then the individual jets themselves, cross feed line on the OMS system, and the heaters for the RMS arm, which is not installed, so that's funny, but they just kind of standardized the insertion checks, so.
Houston, Columbia, thermal
All right,
control system.
topping evaporator heaters are on.
Roger, thermal control system.
We'll go ahead and switch off our secondary oxygen supply. We'll set up our water loop. And we will go ahead and turn off the rate gyro assemblies and the accelerometers.
Columbia, Houston, load out, 201.
Okay, GPC-5 halt. Ops 201. Proceed.
201 complete.
Okay, service mode. GPC-4 execute. Ops 201 proceed. And computer 3 to halt. We'll go ahead and activate radiator flow.
Columbia, Houston, thermal control system to enable.
Ops 202 proceed.
202.
Item 3. Item 1. we'll go ahead and turn that on. And out of curiosity, if I actually do item 15... Nah, okay. That's what I thought. Just
Opening payload bay doors.
wanted to be sure. We'll go ahead, open payload bay doors. And you know what? Why don't we get some light on the subject, too? You can see the latches cycling to open. And there she goes.
Columbia, Houston, deploy radiators.
Release the retention latch. And we will go ahead and deploy radiators. Can't really see that at night, but we should be able to see that in the day. Okay. Item 2, terminate AC power. We'll go ahead and initiate fuel cell purge via computer command purge sequence. We will call spec 69. Spec 69. Fuel cells look good. Spec 88. Environmental control looks good. We'll go ahead and turn off the flash evaporator controls.
Columbia, Houston, activate Star Tracker. Over.
Roger that.
Deploy the
Houston.
star tracker for IMU alignment purposes. Major function to GNC. We'll go ahead and do spec 22, proceed. Item 3, execute. Item 4, execute.
Houston, Columbia, Star Tracker.
And we can see
Houston, copy that.
there is the possibility for the star tracker, of course, to acquire stars which are not the ones that are required. In which case, we would have to manually go through and start fiddling with the sight mode and change between the sight mode and the calibration mode and all of that jazz. But of course, as a simulator from 2000, game really from 2007, she'll work perfectly every time. And when we've acquired the proper stars, aligning the IMU is quite simply as easy as just entering the star align mode with item 13. And then you would just simply type in item 16. That's it. It's automatic as soon as the right stars are required. So it's a very nice system. We can go ahead, and this was not in STS-1, but in later missions they did have a GPS, which they could use for rendezvous navigation purposes. And we can go ahead and open that dump isolation valve. The Q bond was in every space shuttle. It had the purposes of being able to work with comms, but its most important function was for rendezvous. So we will not be using the Q bond antenna to its full potential in this mission, obviously. But you can see she works as an antenna,
Over and out.
which can be used for communications, rendezvous navigations, and also MIAS.
Columbia, continue with mission procedures.
Copy that. Houston.
System checkout is performed at this time. Next event in, and we'll go ahead and perform 2 OMS burns to adjust our orbit. So we will go ahead and verify we're on Ops 202. Item 22, execute. We will set up the auto DAP. Okay. Item 27,
Houston,
item
beginning altitude
23,
adjustments. Auto sequence start.
and arm the OMS. You can see Space Shuttle performing its automatic maneuver towards the burn attitude. And the way that it gets to burn attitude
Houston,
is,
Columbia, altitude adjustment complete.
Copy that, Columbia.
as you can see, a little bit just slightly more interesting than how the Apollo spacecraft would have actually done it. It's definitely one of those things where, just due to the space shuttle's size, autopilot on space shuttle behaves a little bit differently than you would maybe expect to behave. I'm going to go ahead and verify good chat connectivity. Okay. Good chat connectivity. Very good, very good. Sometimes my monitor likes to disconnect from the chat, so I just make sure every once in a while that she's still connected. We'll perform our burn when the space shuttle is local vertical to the Earth's horizon. So it's usually a good way to time when to start your burns. So we'll snap out right about now. No, okay, apparently not. We will do it upside down to local vertical. So still local vertical, but with the Earth facing above us. So another half rev.
Columbia, Houston, confirm OMS burn.
Copy that. Houston, OMS burn in progress.
Okay, OMS burn. We've got a good ignition. We can actually see it out the back. And a good shutdown right on time. Two orbits later, we will prepare for another burn. So we'll go ahead and hit next event. Jumping ahead 2 orbits later. That is a very nice thing about this, so it doesn't take long durations of time like Apollo. Here you just
Houston, beginning
cut right to the
altitude
chase.
adjustment. Auto sequence start.
Roger, Columbia.
Again, watching the space shuttle do a very interesting way to auto maneuver here.
Houston,
Actually,
Columbia, altitude adjustment
that one was
complete.
pretty good, a little more straightforward than the last. A little bit more straightforward than the last. We like that one.
Columbia, Houston,
And
confirm OMS burn.
performing the burn at
Copy
local
that.
vertical.
Houston, OMS burn in progress.
You can see the Earth above us. Very nice. Ignition. And shut down right on time. That completes orbit adjustment. The next test of the space shuttle here in orbit will be a test of its translation systems. You just caught my miss first try, nice. Flight control power is on. We will go ahead and give a test of the different systems. So here, digital autopilot. We'll go ahead and test. If we set her to discontinuous rate, we can go ahead and perform attitude adjustments via rate command like you would expect. If we did it in pulse mode, you can see pulses, and they will actually not zero out automatically. So discontinuous rate is definitely the way that I prefer to fly. And of course, there is also translations. We've got aft, forward, down, up, left, and right. And we can set those to low Z mode. So that's what low Z does. And we can go into high Z mode. And we can see enters very big bursts coming out like that, compared to your standard mode. If we switch to local vertical, this changes the way that the rotation system works. However, if we have control from the back, and this is really interesting, if we have control from the back segment, and we switch it to Z-sense instead of X-sense, now plus and minus go up and down, and then 3 and 9 go forward and backwards. So shuttle translation system can get a little bit confusing at times. But it's all quite interesting. Let's go ahead and next event to our deorbit preparations.
We copy. Go for deorbit.
Very short mission. Setting up our cooling system. We're trapping cold freon here in the radiators. And this takes about a quarter revolution.
Columbia, Houston, KU antenna.
Roger. KU antenna. Power off.
Okay, KU antenna. So we're on spec 33. We'll disable the Ku-band antenna. Set its power to off. And then we will go ahead and stow.
Stow at KU antenna.
There we go. Then it was spec 22. And we'll terminate the star trackers. So item 9, execute. Oops. Item 9, execute. Item 10, execute.
This is Houston, no radiator, over.
We confirm. Stow radiator.
Stow the radiators. latches.
Columbia, activate backup flight system.
Copy that. Backup
And then
flight
we'll
system to enable.
restore our backup flight system and switch to Ops 3 for deorbit. We'll need our rate gyro assemblies and accelerometers for the entry. And we'll open the crossover valve, turn off all the bay lights. Okay. Out of curiosity, can I do like item 4? Nope, okay. She really wants it within its limits, that's fine. Item 1, execute. Payload bay power and close.
Payload bay doors.
Go for Ops 3.
Roger.
Okay,
Ops
here we go.
3.
GPC 4, execute. Ops 201, proceed.
Ops 201. Complete.
GPC 3, start. And we should be good for Ops 301, proceed.
Ops 301. Complete.
We can go ahead and close the Star Tracker doors, which are right here and here.
Columbia, Houston, go for nominal jet.
Columbia. Roger. Out.
Okay, brake heaters, I can tell you, are already good. We'll go ahead and enable the brakes. Verify primary DAP. Anti-skid and nose wheel steering are good. We will start the computer control of the evaporator systems. And then since we're going to be powering up and using the APU as well as the body flaps, we can go ahead and turn off the heaters because they will accumulate heat whilst in use. We don't want them to, as it were, overheat. And we can open up our secondary oxygen system.
Pressure on. Main propulsion system area.
We copy. Houston.
We'll need pressurization through the helium for pressurizing the pneumatics and the gimbaling of the engine.
Houston, Columbia, go for IMU alignment.
Roger.
This
Houston.
is for the purposes of moving the engines out of the way of the drogue chute. As well, we will be dumping helium, small amounts of helium out of the engine bell while we are
Copy that. Houston.
deorbiting to prevent pollution of the engine bells. We will go ahead and do item 34, execute.
Columbia. Initiate.
It does a gimbal check of the OMS engines. We can see that there. That drive is complete. We will get pressure on the boiler and complete APU pre-start. Ops 302, proceed.
Ops 302. Complete.
Spec 50 will pull up our horizontal situation display. And then Spec 51 is just the override display for some systems management, like dumping the forward RCS. So here, and item 44. We'll close the payload vent doors.
APU 1, start.
Roger, APU, start.
We will run on one APU to conserve fuel, but APU 1 will start and it will rise to about 900 psi. Verify both OMS pods are selected. Item 22, item 27,
Houston,
item 23.
Auto sequence start.
Roger, Columbia.
Pressurize the OMS system, and we will go ahead and adjust our attitude
Houston,
for
Columbia,
entry.
altitude adjustment complete.
Copy that, Columbia.
After 2 days, 6 hours, and some change, we will be coming home.
Columbia, Houston. Confirm OMS burn.
Copy that. Houston, OMS burn in progress.
This is a very short 3-minute burn, so it's actually not very short, it is very long. Ignition. Chamber pressure looks good. H dot is, of course, falling. And we can go ahead and do some light time dilation through this burn, right up to shutdown.
Columbia, load ops, 3, 0, 3.
We copy.
Okay, ops 303, proceed.
3, 0, 3, complete.
And we'll go ahead and get our orbit attitude adjusted here. Or our coast attitude, that is. So that we can present ourselves heat shield forward.
Go forward, RCS, dumping.
Roger.
Okay, item 36, execute. And as soon as we hit item 37, we've armed the dump. Let's go ahead and complete that. Item 37, execute.
Houston, Columbia,
Dumping forward RCS.
Copy that, Columbia.
The dump is complete. We'll go ahead and start our other 2 APUs and bring them up to the nominal 3000 psi. And switch it to shutdown to inhibit and AC bus to monitor only. And we will go ahead and start the item 39, execute.
Houston, Columbia,
And it will perform a hydraulic surface check.
Roger.
I don't know how well it's visible, but there she is right there. And the split tail rudder. And even our body flap for trimming purposes. One cycle is complete, so we can go ahead and item 38 to terminate the dump, because that's complete. Item 40 to terminate the control surface check. And we can go ahead and isolate our forward RCS system. And head to Ops 304.
Ops 3, 0, 4, complete.
We can see displays update very nicely. We've got a really nice looking graph here for our entry. I quite like this one compared to the entry monitoring system in Apollo. It's practically the same display, but information is just presented here a little bit nicer than in Apollo.
Houston, confirm loss of communication.
Columbia, Houston, copy that. Out.
And G's are starting to build up. We've got our entry heating started. And we are through peak heating. And here we go, coming up on the graph now.
Houston, Columbia. Do you read?
There we go, following the nominal entry trajectory here.
Houston, this is Columbia. Do you read?
Columbia, Houston, down clear.
Copy that. Houston. Houston, Columbia. Roll reversal.
Ah, roll reversal
Roll
time.
reversal.
These are interesting to watch. The space shuttle will perform roll reversals during its entry in order to ensure that our horizontal situation remains good. Of course, we have ourselves with a certain lift orientation to maintain a good angle during entry so that we don't skip out or burn up. However, as we do that, we are drifting off course from the runway. So small turns like this are performed to change our lift vector to be slightly left or slightly right, allowing us to steer the space shuttle in a various like S turns. If you look at the space shuttle on the map, it would be making a giant S, and this will bleed off velocity very nicely. However, it will, of course, make us deviate from the runway. So as it goes in one direction, to prolong the glide, to bleed off velocity, eventually it hits a dead band, and it's like, oh, we need to face the other way, and so she'll turn the other way, and then the shuttle will start going the other way. So really interesting entry mechanic here. These are performed in Apollo, but in Apollo it just looks so like it's like, of course you expect it, you know, the rolling, it's, but in Space Shuttle, just due to the shuttle shape, it looks a little jank doing roll reversals in the shuttle, but roll reversals, of course, are performed on any spacecraft which has a lift vector controlled reentry.
Columbia, Houston, activate thermal control system.
Thermal control system to enable.
We will flow that cold freon through the shuttle systems now that we've trapped in the radiators earlier. we'll begin cooling the shuttle systems, and this will be just good enough to last for entry. We need to allow positioning of the drag chutes, or positioning of the engines for deployment of the drag chutes. We'll open the thrust vector control isolation valves, and we'll go ahead and turn on our ammonium boiler for cooling.
Hydraulics to enable.
Roger that. Columbia.
We can see we've hit a certain point where aero surfaces activate, and the RCS will continue to assist with the aero surface control right up until we are transonic. Once we're transonic, the RCS will disable, and as soon as we hit subsonic, we will get that sonic boom, and we will be entirely on aero surface control.
Columbia. Flight control. Deploy probes. Over.
Alright, we will deploy our air data probes, and we don't have PDOT tubes in here because, of course, they would burn up, so we've got probes that'll actually deploy out the spacecraft instead. And they are basically like PDOT tubes, but they're deployed out. They don't just like stick out from the side, of course. That would burn off during entry. It would be you know, a pretty rough day for everyone.
That's a good picture.
We'll go ahead and fire up the heads-up display. Get ourselves manual control here. And we will pre-configure our microwave scan landing system, which is the precursor to ILS. I just like to pre-configure it because I like to focus on, you know, the flying here. But here we go, shuttle coming in, making its entry. Blown stick at this point, completely manually by me. And isn't she a beauty? We can see we are RCS controlled in the yaw direction, right up until landing. Everything else, though, we've got no need for the RCS anymore. But up until this point, just a little bit of yaw is required to sort of get that diamond right in that center. So that is the reason we've got a little bit of yaw control here with the RCS. Vertical situation is looking right on the money. And we can see our horizontal situation showing the hack, the heading alignment circle. And we can see we are dumping that helium out of the engine bell to prevent pollution. We got to remember these engine bells are reused, so doing things like dumping helium out the engine bell during the entry and landing are required to maintain their operation for the next shuttle flight. Coming up on the heading alignment circle now.
About a minute to go to the hack. Looking great.
And the space shuttle looks really nice. It's got a really good model for 2007, I think. Here's the hack.
Ceiling at 9,800.
Cloud ceiling at 9,800. It's always 9,800 because it's 2007.
On course.
Copy that, Houston.
Okay, a little bit of a right turn here to get us perfectly matched with that heading alignment circle. and we are perfectly
Copy
lined
that.
up, so left turn. Left turn just enough to match that first circle there with the hack circle display on our horizontal situation. Once that first circle's
Columbia,
predicted
you're on
path
course.
first predicted path circle contacts the heading alignment circle, we know that we've got a good heading there. And we can see that heading alignment circle being performed.
Columbia, you're looking good.
Okay, coming up on audit to 90 here. Just approximately 25-ish more degrees.
On at the 90.
Copy that. Audit the 90.
A little bit difficult when you're, you know, flying by
Columbia,
keyboard and
you're
mouse
looking good.
instead of stick, but these are the woes.
Ceiling at 9,800.
We have the field in sight.
Columbia, you're looking good.
Lined up on final.
We have the field in sight.
Bring it
Copy
down.
that.
Coming up in this display now, so that I can easily arm and deploy the landing gear and the parachutes.
Copy that. 10.
Hanging a little bit left, that's a-okay.
9,000.
Line our trajectory up with the pre-flare indicator
7,000.
on target. And now, as soon as we've got our
10,000.
alignment here, we've got 2 reds, 2
5,000.
whites.
Begin pre-flare.
Bring our trajectory right onto
Columbia,
that circle.
you're looking good.
There she goes, landing gear armed.
3,000.
Standing by for landing gear deploy.
Columbia, you're on course.
We
Okay,
copy.
flare.
2,000.
Alright, 4 whites. Good.
900. 800. 600. 5.
Gear down.
Columbia. Deploy landing gear. 300.
Gears locked.
200. 100. 60. 40. 20.
Okay. Flare up. Touchdown.
Main gear touchdown. Deploy chute. We have
Weight on nose wheel. What's our score, sports fans? Ah, a little off from the center line. Damn. That's okay. Getting the center line is easier when we've got, you know, an actual runway in future missions and not just
Releasing.
the California desert. And we, of course, don't have a stop line either, because desert, and they just spray painted this on the desert floor. So we're going to go ahead and we will permit the use of our carbon braking system, but we must do it in very small stints, as the CBS was only designed for stopping the wheels once you've slowed down after several hundred feet of runway, just to get it perfectly on that stop line. But we don't know where that stop line is because we're just line spray painted on a desert. So we'll go ahead and just use the 1 second burst of our CBS to prevent any overheating and fires. Little stints of the CBS here. And we are now slow enough to hold the CBS for wheel stop.
Light control. Wheel stop.
Perfect
We
touch.
can go ahead and manually retract the split tail,
Welcome home, Columbia.
and that'll do STS-1. Thoughts, opinions, how was that? If you're curious, by the way, here's all the missions. I've flown every single one except for 401, but here they all are. So yeah, how much time are we in here? Let's take a look. We are in 1 hour 30. Okay. I think this is an okay time to stop. Honestly, it took longer to do STS-1 than I originally anticipated. And so I was gonna say, like, oh, we could do STS-8, but... Oh, you know what? There is no RMS arm on STS-8, but either way, it's gonna take a while. This will push us to a ridiculous amount of time. So I think we'll... Yeah, 6 days, 1 hour, 8 minutes, 43 seconds. I think we'll go ahead and we'll call it here. Any news on the second edition they are working on? No news. I know that one of the people in NASP is a beta tester for that, but I can't really say anything about it. They are probably under NDA, like I don't know what's available and what's not, so yeah. Also Ares 1X is in here, because of course it is. Yeah, I think that's probably gonna be all for today, so. And then Arco says to tag his channel in the description of the channel intro that's up on the home page, and I'll go ahead and do that right away. So thank you all for stopping by. It's been an absolute pleasure, and I'll see you all here on the flip side. Bye-bye.